Hey everyone, and welcome to our webcast. From Playbooks to Robocop, the evolution of SOC automation. Not sure about the name or the title, but it's there now, so we'll have to live with it. But welcome first of all, and thank you for taking some time to be with us tonight. I'm saying tonight because I'm based in Belgium. It's now 5 p.m. On the dot. Well, almost because we're 1 minute ahead. Yeah, I'm seeing that there's quite a few people who've joined us from all over the world a bit. Well, I don't know your geographical locations, but I'm just making some wild assumptions, like a true AI agent would. But so thanks for joining us. I'm Erik van Buggenhout. I'm a SAN senior instructor and author for the Purple Team courseware. I'm also at Enviso responsible for managed security services. So I look basically after our managed detection and response offering and post-traumatic vulnerability management, where of course we're trying to deliver quality services with a high degree of automation. So this is a very on-point topic for me. I don't know, Wouter, do you want to quickly introduce yourself as well? Feel free to go for it.
Yeah, sure. My name is Wouter Stinkens, also based in Belgium. I think I've been working at Enviso for almost 7 years now, which is a very long time. As Eric said, I'm the head of the automation engineering team in our managed services. I think I think I've been doing automation with SOC platforms for 4 to 5 years now. I think since the beginning of our SOC. And we do already rely heavily on AI. It used to be the AI prompts, and now we're actually investigating how to use the AI agents, and that's some of the things, some of my investigation, some of my research I want to share with you guys today.
Yeah, thanks a lot, Wouter. And well, it's a long time, but also not. Time flies when you're having fun. So I'll
That's true, yes.
we'll take that as a compliment. So what do we have in store for you today or during this webcast? First up, a short problem statement. To be fair, the problem statement is not that hard. We all know automation is key. We're going to look at traditional playbook automation. So I'll be talking about how could you automate trivial tasks and what is a bit the initial idea behind SOAR. This has been around for a while now, but I just want to make a couple of good points on how we've actually approached SOAR automation quite well, honestly. I must say the automation rate in our managed service is quite high. And it's all a bit of a spoiler for a conclusion. Playbook-based automation is going nowhere. Right? It's going to be there because there's just things where playbook-based automation makes much more sense for. But we'll also look into, and then I think that's the next big topic, the rise of AI, which is from chatbots, basically simple things that you ask a variety of different questions to truly agents that you can use in a structured way to get a certain output and to even execute certain actions. So we'll look at some of experiments. We'll look at the typical use cases. We'll look at what a layered architecture could look like. How could you combine these multiple methods of automation? And we're going to make it very practical. So we have quite a few demos. Well, it's mostly Wouter who has prepared the demo, so thanks a lot for that, Wouter. We'll be looking in quite a few examples. We're really going to show what we've done, the research that we've done. We're also going to share a GitHub repository that we published actually just today, which includes a lot of the code that's behind our experiments. So you can also you can tamper with it a bit further. I think it's quite useful to play with it on your own to see, okay, how can this work and how can I use it? I would not deploy it immediately in production just yet, but well, you can. But if it breaks, you get to keep both pieces, right? That's what they typically say. But I think it's just an interesting toolkit to see, okay, but how could this be used? If you have any questions, of course, you can ask them. There's a Q&A here. There's a chat. We'll typically take some time at the end of the presentation to walk through your questions. So first up, I think that the problem statement, of course, the problem statement of any typical SOC, it's okay. There's a wild number of different things being thrown at SOC analysts, right? There's brute force attacks, malware, phishing, a variety of different events, a variety of different, well, sometimes easy things to analyze, a high volume, right? Because those darn detection engineers just keep on adding additional rules, additional analytics, because there's a continuous request to increase the overall coverage, if you will, the detection coverage, the overall visibility, and of course the business keeps on adding new products. There's new things. The IT environment is never static; it keeps on expanding. So just fundamentally, SOC analysts get overwhelmed every single day with different alerts. It's a common problem, not something I'm going to spend too much time on. I'm sure we're all aware, and we've potentially seen that before. And while that's fun at the beginning, gets a bit tiresome after a little while if you just get smashed with alerts all the time, and that leads to analyst burnout, alert fatigue, all of the usual symptoms. So how do you solve that? Well, honestly, it's about an automation first approach. Automation is not a nice to have. It's not, oh, but we can do some automation on the side. No, it's a core process. It's something that you need to have in security operations. And it even goes beyond just detection and response, right? Some other examples of where automation is useful and even pivotal is things like infrastructure as code. We've all heard things like Terraform that can be used to automatically deploy certain workloads. Desired state configuration, things like a PowerShell DSC or Ansible, tools like that, to really double check, is it still configured as we would want it to be? A lot of these things are relatively trivial. It's not rocket science. It's about automating and doing the trivial repetitive tasks in a consistently high quality way. And that's where automation, of course, shines. Then, of course, SOAR, I think, one of those big ones, automate repetitive security tasks, coordinate tooling. So SOAR, of course, stands for security orchestration, automation and response. The idea is to truly have one layer that can coordinate all of the different automation actions that we would do when security incidents are detected. And we'll zoom in on that quite a bit. And then, of course, the new kid on the block is the AI prompts and agents even, because in 2025, it's of course all about agents, right? The AI hype is still there, but now we've focused it on really truly AI agents. And we'll talk a little bit about what that means in just a second. So automation is key. I think we've established that. That's really the big one that we want to go after. Now, what does playbook-based automation look like? Let's really talk about SOAR for a quick second. So as we mentioned, SOAR is security orchestration, automation, and response. The idea is that you can integrate with a variety of different security tools, be that SIEM platforms, XDR, EDR, NDR. I don't know when we'll stop inventing acronyms, but well, we haven't gone through the entire alphabet yet, so there's much more that we can do. But the idea is to have a central layer that you can integrate with a variety of different security tools that you have, both input sources with security alerts, but also connections towards different platforms that you can use to perform remediation actions, for example. Then you have, of course, reporting insights. So you want to have that central layer to get statistics. You want to have what we like to call, and I hate it, but I also like it, the holy grail, right? The single pane of glass for analysts, where they see everything and they see, okay, this is an alert. There's context, there's enrichment. I can just click a button to remediate it. That's the principle. Can we achieve that? Can we have a combination of automation logic and playbooks, and then maybe an analyst interface? That's typically what a lot of these SOAR platforms are trying to achieve. So one centralized platform, really, where all of that can happen. Now, what are some examples of SOAR platforms? To be fair, not all of these on the slide are actually SOAR platforms. Some of these are also just basically automation engines, if you will. There's things like a Sentinel. Microsoft is pretty big on calling themselves I think they call it the Unified Security Operations Dashboard with Sentinel XDR. A lot of their automation logic would then be in Azure Logic Apps. Can be a bit painful to build all of that. There's also people who build a lot of things with Azure Functions. Very interesting presentation, by the way, from the people at Falcon Force, who did an amazing presentation, which is called From SOAR, like SORE, from painful, to SOAR, SOAR, using Azure Functions. And that was quite interesting. So they basically said it's a bit of a mess to do this in Logic Apps, but if you want to go Microsoft native, you can do a lot of stuff with Azure Functions. So quite interesting. Then there's, of course, probably the big one is Palo Alto Cortex XSOAR, has been around for a while. Massive beast, very capable. We'll talk about that in a bit. We actually use it quite a bit in some of our work in MSS, in our managed security services, but it's an interesting framework to look at as typical things like multi-tenancy, all of that. So it's really designed a bit more for those things. Google SecOps, which is basically used to be Simplify, got acquired by our dear friends over at Google, and so now it's part of Google SecOps. Things like Tines and Tracecat are also out there. Times is pretty well known. It's a bit more the no-code automation. So the idea is that you have drag and drop, so you can just connect things all together. And then you've got Tracecat, which is basically promising to be an open source variation of Times. There's others like Splunk, for example, which has Phantom. But so that gives you a bit of an idea that there's quite a variety of different platforms out there. But what's the idea behind the SOAR engine is that you typically want to build a framework, right? You want to build a combination of logical playbooks that you can fit together. And honestly, this is actually how we build it on our side. So that's in our managed security services, the logic that we've built. We basically say, okay, but we start with ingesting security events. Well, that's the start. You start with a security event, and then you start getting additional context. So you enrich that. You start getting additional information about that event. What does that mean? Okay, I have a security event that includes a user. It includes IP addresses, certain, let's call it attributes. You enrich them. Who is that user? What privileges does that user have in AD? What's that IP address? What's the GUI? You do a GeoIP lookup of the IP address. Is it on any known denial lists? That kind of stuff. So you enrich that event further. And then you try to start making an analysis. So you want to figure out, is this a true positive or a false positive? When you're dealing with SOAR playbooks, it's fundamentally a bunch of if-thens, right? You do a lot of checks to see, okay, but what if this, what if that, is it this, is it that? And you try to get to a conclusive, to try to get to a conclusive, verdict. Is it true positive? Is it a false positive? The first thing that we actually initially started doing in our managed security services was to use this mostly to weed out all of the false positives. Because if you can do that well, it allows you to be a bit more tolerant when it comes to new detection rules. If you could find a way to easily spot this is a false positive, get rid of those already, that already helps with the first level of alert fatigue. Then, of course, the next trick is, okay, but is it a true positive or is it non-conclusive? That's where the fun starts. It's trying to figure out, okay, but what is this now? And that's, of course, where you can start adding additional checks, additional analysis. But you can see here that at one point, those non-conclusives or true positives, they might end up with the SOC analyst. Depends a bit on how you configure it. What we do when it's a true positive, if our target operating model allows it, we could also immediately take a remediation action because the SOAR playbooks can perfectly call a certain API to trigger a remediation action on a certain security tool. Like, fun fact, at the previous meeting, I said kill a user. You obviously don't want to kill a user. You might want to kill a process, but you might want to block a user, reset the user password, stuff like that. So a typical remediation action. Killing a user, I was just thinking maybe there's a way, but not a legal way in any case. But just to point out, the SOAR platform can go quite far. If you have an entire framework built, it's about figuring out where do you put the human in the loop. And the human doesn't always have to be in the loop, but he has to be there somewhere in case certain actions you don't want to automate end to end, right? So that's a bit the idea behind that. Important to note here is what you need is an entire framework. You cannot just have one little playbook or one automation. You need to have a structured way of running through this. And we'll actually get back to that. In security operations, structure is extremely important. It's one of those fundamental things that we need. So maybe a little bit more detail on this. How do we do event ingestion? What we actually do is we work with a process that we call classification. And this is just a silly example of what we do. But the idea is you cannot have playbooks for every single alert, right? Doesn't work. It's not scalable because then people would go bonkers because you need a team to continuously maintain all of these playbooks. So what we do is we basically say, okay, but there are a limited number of what we call incident classifications or incident types. The one here on the right-hand side is an access anomaly. That's just an example that we're using. And for every one of those incident classifications, we have a number of incident attributes which are important. Basically, attributes that we need to perform further analysis afterwards. We also ensure that there's data source uniformity so that you know that, okay, whether this now comes from an EDR, from a SIEM, from a different security source, it all gets normalized, if you will. That's the principle behind it. Because then you can just use an access anomaly playbook, right? It's a playbook that's used to perform analysis on access anomaly events. So here's a practical example. 3 different raw alerts, unfamiliar sign-ins, impossible travel activity, infrequent country, stuff like that. But they all end up as an access anomaly. That's what they are. And then you extract a number of different fields from that, and you go from there. So that's, of course, the work, and you already see where this is going. You need to put in the work to create those instant classifications. You need to structure things, and you need to have a certain logic. In return of that, of course, you get control. Now imagine then you have a geographically improbable login for user Erik van Buggenhout. That's fine. Then you build a playbook to start running through that entirely. And you do a variety of different actions, not rocket science, just a consistent way of enriching that. Add the privileges, that user. What privileges that user have? Do we have any insights on the reputation of the source IP address in this authentication? Can we check whether Erik actually used MFA or not in this authentication attempt? Important, right? Yes, we can bypass MFA, but the fact that they used it is an interesting data point. Add historic locations. Where does Erik usually authenticate from? Does he usually authenticate from Brussels in Belgium, or is it usually from Washington, DC in the US? I don't know. It's to get context. Security risk scores, information about workstation security alerts. Okay, but Erik's workstation, do we have current active security events on Erik's workstation? If so, could be another reason to assume there might be something wrong here. So you get context, you enrich that event with a lot of information. And then you try to make a decision with the playbook. Say, okay, but I have all of these checks. If 7 out of 10 of these flag, and you can put a weight in there, of course, that's all what you define up front in those playbooks. You try to make you try to confirm, yes, this is a true positive or a false positive. And then, of course, you can go into remediation playbooks, as we said, and go on like that. I think this makes sense, but it's a very simple example of this, what you would typically build with SOAR playbooks. That's, of course, the thing with SOAR playbooks. They can do anything or they can do nothing. It does depend on what you do with it, because most commercial SOAR platforms, they basically are large lists of integrations and connectors. It's basically like buying a set of Legos. There's a ton of things you can do with it, but you need to know what you're going to build with it. Yes, they come with content, so usually they have pre-built content packs. But remember, you need to create your own framework, right? You need to create something end-to-end that all works together. So yes, you can reuse some content, you can find community stuff, but there is nonetheless a significant investment to be done to create and maintain your automation framework, because you need to have those playbooks, you need to fine-tune them continuously, connect them, make sure they keep on running. It's also not just a one-off, because that's the whole point. Those things need to keep on going. The big advantage, though, of this is once you've done the investment and once it's running and you're maintaining it, it's relatively cheap because it's fast and it's running. And we'll get to that once we get into AI. AI is fun. It's a lot of fun, but of course there's consumptions, there's tokens to be taken into account, and Wouter will discuss that in a bit. But that's an important differentiator that we'll see in the next stuff. So can we just have AI handle all of these security events? So let's have a chat on AI. We started it back in 2023 by saying, okay, but can't we use AI prompts as part of those analysis playbooks, right? So combining SOAR playbooks with some AI. Mixed results. Not terrible, but what you see is that sometimes it comes back with very good feedback. In this case, what we're trying to do is we're trying to analyze phishing emails. So we're trying to figure out, is this actually a user-reported phishing mail? Is that truly a phishing email or not? The problem, though, is that it's not always consistent and reliable, sometimes even prone to hallucinations. And that can be okay in some situations, but in security operations, the predictability of outcome is extremely important. So that's something that you have to deal with. You need to know that, okay, but if you send in a potential phishing mail and it's actually a phishing mail, then the result has to be every time, yes, it's a phishing mail. It can be, I sent it today, it's okay, tomorrow it's a phishing mail. So that kind of analysis is a very interesting ballgame. So you need to figure out how can we get consistency in there. Then we get into what we call generative AI versus agentic AI, where, again, today it's all about, we have AI agents, right? And the idea, of course, generative AI, think of ChatGPT, it's about content generation, text, images, code. Typically has low autonomy because you give it very specific instructions. You ask it to do something and it returns something. It doesn't really have memory or context. Except, of course, if you're using RAG-based solutions where they can actually fetch information from PDFs, for example, stuff like that. But usually they don't have a lot of memory or context, if you will. Limited decision-making, because, of course, it all depends on how you prompt it. So that's generative AI, right? We're all very capable. We're all very aware of how that works. When it comes to agentic AI, of course, you start getting into more complex workflows where you can potentially achieve a higher level of autonomy. So what you try to do is maintain context across tasks so that they know I need to achieve this task. I can potentially collaborate with other agents, but I have a specific task to do. It's not just a prompt, so they try to execute a task correctly. You might think that these are mutually exclusive, but they're actually not, because what you'll often see is that you actually use generative AI with AI agents. Because think of AutoGPT, Crew AI, AutoGen, which we'll discuss in a second. They typically use generative AI models to be able to do their bidding. But so what does that look like? Here are the top or the big AI agent frameworks out there at the moment. There's Crew AI, which is fairly well known. There's AutoGen from Microsoft, and there's LangChain. I'll zoom in a little bit more on the two left ones. LangChain, firstly, is basically, yeah, it's both. It can support multiple agents, but it's not as structured. It's typically a chain for task automation. So is it truly an agent framework? Not really in the sense of a Crew AI and an AutoGen. Because what you see with Crew AI and AutoGen is that you truly have multi-gen collaboration, agent collaboration frameworks, if you will. Both have their upsides and downsides. We've actually played with both of them, so you'll see that in a second. But the idea there is that you predefine agents with certain roles and task delegations, so they know what they need to do, what their role is in the bigger picture. And then, of course, they communicate with one another. So this is important. So they both communicate with one another, they share responsibilities, and that's the whole point. They try to collectively figure out what they need to do. Here's an example of a Crew AI in its structure. You can see that every agent indeed is part of a collective, and they all have distinct abilities and duties. You can configure tools that they have access to, like you can access Sentinel with XYZ. They could have information that they could fetch. They could have internet access to find certain things, but important, you typically want to give them a very specific role that they can excel at. You want to make them, well, very narrow so that they know, okay, this is my specific role, because you can build some governance around it to make sure that, okay, everything keeps on going in the right way. Not perfect, and we'll see why in a bit, but that's a bit the principle behind it. So on this slide, we've actually made an example using, hey, here's a threat intel analyst. So you just basically define a role and you get that going. One interesting thing I just want to briefly mention, we actually presented this last year at RSA. And there's actually a new RSA talk coming up next month by myself and Jeroen. This time we're talking about using AI agents in purple teaming, but the one of last year was quite interesting. It was about trying to use OpenAI/ChatGPT to automate EDR bypasses. And we actually used AutoGen for that. And here's a small example of what we built there. What we did was basically we said, okay, but we built a number of different agents and they can talk to, for example, the Caldera API. I'm not sure if you're familiar with Caldera, but it's a BAS tool, breach attack simulation. And the idea is that those agents they will try to emulate, or in this case, not really emulate, but they try to bypass EDRs autonomously. That was the idea. That was the problem statement. So how did that work? We basically build an entire setup or a governance where they communicate with one another. They try to identify or fingerprint what EDR is running on the system, then try to figure out for that specific EDR, what are the bypass techniques, and then they actually try to implement them using Caldera. It was pretty fun. But here it is. It was pretty fun. This kind of shenanigans you can play with because we're trying to do some EDR bypasses and we can see how far we go. When you're running a 24/7 security operation, you're doing managed detection and response, for example, it cannot be fun. Well, it can be fun, but it has to be predictable. You cannot have like, sometimes it works. It doesn't always work, but usually it does. Like 60% of the time it works all of the time, right? That doesn't work. This you need reliability, and that's really a key thing. And maybe here a very small demo. So this is actually what we presented at RSA. That presentation is available if you would want to. But here we're actually using, we deployed a Caldera agent on a system, and we're now using our, a Caldera backdoor, not an agent, a C2, if you will, a payload. And now we're using our agents to basically talk to Caldera through the API. What's very interesting is you can see that the different agents, they're actually talking to one another now. They're figuring out, we need to get the privileges on the system. So they're trying to discuss with one another, how do we do that? And this is already the result. So let me just pause it for a second. But what's quite neat is that they know how to interact with Caldera. Why? because we basically gave the Caldera API to one of those agents to say, this is how Caldera works. So what it does is it actually reads the API documentation. And then it figures out that's how I need to call Caldera, which is quite amazing. So you don't have to hard code that. You can actually get it to do that. A very interesting thing that we found last year was that there was a mistake or a typo in the Caldera API documentation. And that's why our bot kept on failing, because it was just it was reading the API and using it. As a human, you would have immediately realized the typo and not used that. You would have corrected it yourself. But of course, the AI bot didn't. It said, okay, but that's the API call I need to make. So fun fact, little background story. But so you can see that, okay, it figures out the user privileges. It knows what command to run through Caldera. And then what it's going to try to do is to try to detect the running EDR. So this is a pretty interesting one. So again, it's starting to talk to Caldera. And it's saying, okay, how can we know what are the different EDRs? You'll actually see here that it has a GitHub tool available, and it figured out, okay, but there's actually an EDR telemetry GitHub page, which some of you might know about, which lists, okay, these are all the different EDRs. That's where their visibility gaps are. So it's trying to get that context to figure out what are the different EDR tools available. It also fetches, indeed, what are the different EDR products which are published on that GitHub page. There we go. The next step that it's doing, it's enumerating all of the Windows services on the system. So it's trying to figure out, okay, but what are the Windows services? Because those Windows services might give me an insight into what is the EDR that's running. And here, indeed, Elastic Endpoint, part of Elastic Security, okay, doesn't take a genius to figure out Elastic is running on the system. The right-hand screen, by the way, is the system. Just to see, it's very happy. It hasn't been touched yet. Then trying to identify those EDR bypass techniques. I discussed that already, but you'll see that it's actually going to try to figure out for Elastic specifically, where are the potential visibility gaps? Because no EDR is perfect, right? They all have certain gaps. And what this one is trying to do is we're trying to showcase, can you avoid the complexity of figuring out how to do an EDR bypass by having AI do it for you, by using publicly available sources? And here's a small gap. File downloads using PowerShell are apparently not by default flagged. So that's an interesting one. So we can now say, oh, let's try to use that. So now we're basically opening the C drive here for a second on the right-hand side, just to show what's on that system. And now we're actually asking it to elevate privileges. So we're asking our Caldera agent to see, can you do a privilege escalation on that system? Because we're running with standard privileges, can we get admin privileges? And what you'll see that it figures out, and that's again quite interesting to see how that works. It's a bit more, it's enumerating all of the services. It figures out that there's a service where the pod is not surrounded by quotes. So some of you might know that, but if you don't have double quotes around services, you might have a pod hijacking attack basically that you can do. Here you can see that this service, C program files, TFTPD 64 se.exe and so on. You can see here that there's no double quote around the C program files. So it means that if that service starts, it will try first C program.exe. So if you can put a C program.exe and you can restart the service, then you could potentially escalate your privileges, right? By putting a malicious payload as cprogram.exe. And that's exactly what we're going to do now. What this system will do, it will say, oh, interesting, I have an opportunity here, so I can do that. So it goes on, and here you can see doing the download invoke web request, it's downloading that payload. So it's putting that there, and you'll see that indeed cprogram.exe appears on the right-hand side. Amazing. Perfect. Now, that doesn't do anything just yet. Why not? Because, well, we need to restart the service, but if you don't have administrative privileges, you cannot. So we're just cheating here for a second and we're restarting the machine, which would, in a real life scenario, you probably have to just wait a little bit before that could work. So it's going to restart. I'm just going to skip ahead here a bit, but you'll see that once it boots up again, boom, you'll see that, oh, there's an additional payload actually now, and this one is running with elevated privileges. So that's pretty nice. So we've now been able to elevate privileges. Now I'm going to, in the interest of time, going to move ahead a bit. But what you see is that it's quite capable, but I will tell you, it took us quite some time to get to work, and it was still a little bit unreliable. We had to record it a few times to get it to work really well in that RSA demo, and that's something that, of course, you want to avoid. Now, That's EDR bypasses. Could you also define SOC analyst with Crew AI? Well, there's a few things you can do. Here's an example of a definition with a lot of background information, right? As you are a seasoned security operations center analyst working in an MDR provider that was XYZ. So you can configure SOC analyst roles, but how effective are they really? And over to Wouter to zoom in on this a little bit more.
Yeah. So as you can see in the slide, what I tried to do is, the previous slide was, can you build a SOC analyst with Crew AI? I tried to do this with AutoGen. I think the research I did, the research goal was, okay, can we actually replace our SOC analyst and even our SOAR engineers with AI agent? Here in the bottom, what you do is you have define the agents, and those agents, they actually have tools. Well, they have the capability to use tools. I'll show you this in the code a bit later when I start the demo. And the collection of these agents and tools, they form a team. Within AutoGen, you have multiple different types of team. The team type I chose was the Swarm. What does this do? In the Swarm, you actually have one central agent who does all of the coordination between all of the other agents. That's basically it. And here in the bottom, you can actually see the task that I gave to the team I created. This is the last iteration of the task. I'll show you in the demo how I actually got to this. What do I ask the team to do? Is first get the Microsoft Sentinel with this ID, get all of the alerts and the entities, and do a structured analysis of the incident by coordinating with the supporting agents. Do KQL queries to validate your findings, and determine if it's a true positive, false positive, harmless, or insufficient, and provide close notes. So basically, actually what our SOC analysts do on a day-to-day basis for any normal incident within Sentinel. Go to the next slide. Here you can see the actual SOC analyst agents, which I described. That's already what Erik mentioned. You really need to clearly define what its role is, what it can do, what it can't do, and especially in the Swarm type, the Swarm team type, you really need to say for which tasks do I use which agent. That's very important. Here you can also see you have in AutoGen. You define an analyst. You have multiple. You define an agent. You have multiple agent types. The assistant agent is the most basic one, but you have other ones available. I think you have a code execution agent, a user proxy agent, which allows a human to actually give their input. I also have a demo in this. And in any agent instantiation, you have a description and a system message. That description is basically who are you, what is your role, and the system message is, okay, what do you do, how do you need to do it? Also very important to say what it shouldn't do. That's also something that I show in the demo. Next slide, please. Here you can see the other agents I defined. I have the SOC analyst agent, which is the main agent that does all of the coordination. And then I defined 3 additional agents. One, the Sentinel info agent, is to get all of the information from Sentinel. I also have an XOR info agent. It actually does the same thing. The idea behind this was, you'll see that in my demo also, the first demos, we tried to just get the information from Sentinel and then see if we can do the analysis there. But in our SOC, we use XOR, and we also have additional enriched information available in XOR. We already have those analysis playbook, which Erik described, already running in there. So actually, it would also be very interesting to get this information and then feed that into the SOC analyst agent. This is also very interesting to see, okay, if an AI analyst cannot reach a reliable conclusion just by itself, what happens if we run it after the SOC analysis playbooks that we already have created? And then as a third agent I created was an agent to actually do KQL queries to Sentinel. Also super interesting. I think, and the tools we gave it available was actually executing the KQL queries, but and AI has the tendency to sometimes do some hallucinations. What I've seen is that, okay, if an AI creates a large language model, creates a KQL query, it can actually either make up table names or table properties, or use stable properties it knows from its training data, but it's actually not available in the Sentinel. So I also implemented a tool which actually gets the tables from Sentinel, which have information, and then see this entire schema. So this actually improves the quality of the KQL queries created by the large language model. Next slide, please. Here you can see on the left the models I've used. For us, we use Azure OpenAI. It's an OpenAI implementation on top of Azure. This allows us to actually send client data to the model. If you look at the documentation from Microsoft, Microsoft clearly states that all data sent to this OpenAI instance is not used for training, and it actually remains within the confines of your Azure subscription, your Azure environment. Which is super important for data residency reasons. Our customers do not want their data used to actually train all of the AI models. And on the right, you can see some of the tools I've implemented. The way the tools work is, again, you have a wide range of tools available within AutoGen, but you also have the ability to implement custom tools. So basically, if you can write a function in Python, you can use it as a tool within your agent. Next slide, please. Ah. Okay.
Sorry,
no,
it was going a bit faster, but I'm back on the previous one.
Okay.
Yeah.
Well, I guess it's demo time now, so let me quickly share my screen.
Perfect.
I'm not used to using Zoom, so it's always a bit of a.
Well, while you're getting your screen, I'll finish up this one real quick. But there's also commercial AI agents out there. Just so you know, it's a pretty big push at the moment. There's Microsoft, which I think yesterday or day before released their Copilot for security agents nowadays. So they're pushing very heavy on that. There's a dedicated providers like Dropzone, which is basically selling AI agents that you can use in your SOC, similar to Prophet. The typical usual suspects, CrowdStrike, Palo Alto, they're all going into this direction. Quite interesting, but just know that there's also a lot of things you can build yourself. So it's a bit of a consideration to make. But I'll let Wouter explain it a bit further as well during the demo.
Yeah. Can you see my screen?
Yes, all good.
Okay, good. As Erik said, this entire demo will be available on our GitHub page from Inviso. I think you're going to share the link at the end of the presentation. Maybe I'll quickly just walk you through all of the code in the repository to see how you guys can actually use this yourself. It's written in Python. AutoGen is a Python framework. As any Python project, you start with installing the pip modules. Secondly, what you need for this to actually run in your own environment is Microsoft Sentinel, a Microsoft Sentinel environment, and Azure OpenAI instance. What you then should do is basically copy the env file, populate all of the variables with your own variables, and then you can actually start using it. Quickly walking through the repository itself. Here, all of the models are defined. As I said, we use Azure OpenAI. And what we actually use is we use two different models. We use the GTP 4.0 model and the GTP 4.0 mini model. Reason for that is basically cost. And that's also something I want to quickly cover. If you go to the documentation of the Azure OpenAI and then scroll a bit down, one thing, if you want to implement this yourself or deploy this yourself, be very careful which region you deploy the Azure, I think Azure AI Foundry or the Azure AI services. They rebrand it every month or something. So, but you have to be very careful which region you deploy it in. If you already look here, you can already see for Europe, it's not actually available in all of the regions. I think we are currently in France Central, but with our previous implementation, we needed to be in Sweden. I think before that, we need to be in Swiss to actually get the latest models. So which Azure region you're using for this, it really matters because not all models are always available. If you then look at the pricing of actually the consumption of this is always done on 1 million tokens. So you think, oh, 1 million tokens, I can do everything with it. It's a lot, but that's actually not the case. We will see later that actually 1 million tokens is pretty quickly consumed. And if you then look at the pricing, there is a pricing between what you put into the model and what you get out of the model. And in general, there is a lot more data you feed into the model than you get out of it. If you look at this is the brand new, the newest version of the GPT model, and here it's okay pricing. It's €71. I think the models that we're currently using is the GTP 4.0, and if you then scroll down, this one, okay, this is already a different price. This is €2.3 per million tokens for in, and out is 9.5. So that's already a lot cheaper. But what the other model we're also using is the mini one. And see, there is a factor of 20 cheaper actually. So really what you need to think about is which model do I use for what? Of course, the more expensive models are much more capable. If you would run everything within the mini models, you will really see a quality difference. But for some tasks, some agents, specifically the ones that we use to get the Sentinel information, it's actually not that, it's not required to run on a very advanced model. Okay, here in the tools folder, you'll see all of the tools we defined. Basically here you define the tools. In the utils, you'll see the functions which actually do these tools. Have a quick look at it. It's pretty interesting. I think this allows you to implement all of the tools yourself. And let's start with the first demo. So basically, this was the first demo I created. The first thing I wondered, okay, how can we use these agents? What is an agent actually? Basically, what an agent is, it's you send a prompt to a large language model and you give it tools. The tools it can, here you define basically the tools it can use. These are the tools we've defined. Basically, all of these tools are for getting Sentinel information, information from Sentinel. And let's see what we can do. So as an experiment, first task I created was receive the get the Microsoft Sentinel ID, give a summary of the incident, and create a detailed step-by-step analysis procedures, including the KQL queries that should be executed. And let's see if this model actually knows how to analyze security incidents. So let's pray to the demo gods that this will work. Of course not. Let's okay, let's try again. No, where is it? Wait, let me just restart my Visual Studio Code. Okay, let's try this again. Okay, no. Here we go. So here you'll see, okay, it's actually sending everything to the large language model, and we already have the result. Let's see what it did. Basically, it got the incident. It actually extracted all of the information from the incident. It's already interesting. It got all of the alerts, got all of the entities, which are the indicators in Sentinel, and then creates a step-by-step analysis procedure. Okay, let's see what it actually says. Okay, we'll determine the legitimacy of the autonomous IP used. It looks good. And here you are already the first KQL query. It's actually trying to see if there has been some traffic from Azure activity, but Azure activity is the Azure diagnostic log. So okay, it's already a bit questionable. And here, okay, it checks the user. Okay. So what do we need to do? True positive, conclude that the incident is a real threat. Okay, if the IP is associated with malicious activity. False positive, mark the incident as false positive. Okay, so first conclusion, okay, you can parse the incident and or can automatically get it. KQL queries are a bit questionable, and the conclusion, okay. But what actually would be interesting is to know what it actually did in the background. What did the agent do? Which tools did it use? And then we can run the second demo. And this will actually print all of the messages that the agents send to each other. And that's actually how they communicate through messages. In the first demo, we just printed the result. And now let's see what the agents are talking about and what they're doing and which tools they're used. Okay, already a lot more output. Let's go from the beginning. So here you can see the SOC analyst. The SOC analyst is actually calling some functions. And here you can see which function it actually gets. This is the actual result. So here you can actually see the JSON data returned from the API. Okay, and here you can actually see it's called multiple functions. And here you can see it basically gets the JSON data, extracts all of the information, and then actually creates a step-by-step analysis procedure. And here you can already see an analysis procedure, but it's actually pretty different than the previous one. Here it says, okay, first check the sign-in logs. The other one was checking the Azure activity logs. And that's also already something that you can see. When you do these any prompt to an OpenAI model, and especially with the agent, is output differs every time. It's very difficult to get like a consistent result. That's already one of the findings that we have. The nice thing about here is here you can actually, if you print all of the internal messages between the agents, you can actually very detailed see, okay, this is how much it costs. And this is already 1,000 tokens, and this is 1,000 prompt, 2,000 prompt tokens, a bit more than 1,000 completion tokens. Doesn't seem much, but this is actually a very simple question you ask the agent. So yeah, you can imagine that if you run this at scale and a lot more prompts, could actually become pretty expensive. So okay, now we asked it create a detailed procedure to analyze the incident. Maybe let's also do it. Let's just ask the agent to actually do the analysis. Retrieve. What I ask it here is analyze the security incident by performing additional KQL queries, and then give it a close reason, impacted harmless, false positive, or insufficient information, and provide close notes. So let's see what this actually does. So here we can see the same thing. The SOC analyst calls some functions to get the information from Sentinel. Here you can see the functions which are called. This is all of the data that returns. And here you can see the summary of the incident, the detailed analysis. But it actually, what it didn't do was didn't do any KQL queries, which we actually specifically asked it to do. And the reason for that is that an agent by itself, what it actually does is give it, it can send a prompt to a large language model, use a tool, and then reflect on the tool. Usually, if you look at the documentation on AutoGen, what do they say is if your tool doesn't have human readable output, then you need to reflect on it. Specifically, like here, the output of the Sentinel API, that's just the JSON data, so that's not human readable. So we need actually an additional prompt to reflect on it. But so here we can actually see, okay, yeah, we didn't actually do any analysis, and that's where the teams come in. Here I still have just one agent, but for these I create a team. Within, as I said, within AutoGen, we have multiple forms of team. The one I eventually used was the swarm, but actually the standard one is the round robin. What does it mean? It's actually like round robin DNS. It goes through all of the available agents one by one and just lets them do their thing. What you also in a team, what you also need to define is a termination condition. So basically, if you don't do this, it will just continuously talk to each other, send messages to each other. So here specifically, I say, okay, return terminate when you have concluded your analysis. And here you say, as a termination condition, it's a text mention termination. Basically, if this whole thing sees terminate, it stops. So yeah, let's try running this one too. So here you can again see it gets the Sentinel information. Here you can see that it actually analyzes a bit. So let's see. And here you can see that it actually starts executing KQL queries, which is already interesting. Here it queries the sign-in logs on this IP. So actually you can see, okay, there are multiple sign-ins from this IP, from this user. It's doing some additional queries, so also very interesting just to verify the data. And here you can actually already see that what I asked to do was to find a close reason and close nodes. You would expect it says terminate now, but no, it actually doesn't. So that's also something I've already mentioned, that you need to be really clear into how you define description, the system message, when does it stop, when does it not stop. So here you can still see, okay, it's still executing some functions. Are we done yet? Okay, and here eventually it has said terminate. So what do we say? Okay, incident closed with reason false positive. We defined some close nodes, and these define the steps taken. I think, okay, we're almost, I just pressed for time a bit, so I'll just skip running it again. But what you'll see is sometimes if you run it again, it will actually come to a different conclusion. What you would also sometimes see is that the Sentinel queries executed aren't always really, the tables don't exist, the queries are not right. And what it then tries to do, it will see that it goes into error and start rewriting it. But what's actually a better idea to do is make dedicated agents with their specific tasks. So basically here, I created, as I said before, one agent to get the Sentinel info. And this is this dedicated agent to a dedicated agent to do the KQL queries and to build them. You're a dedicated KQL builder. So well, let's see if this actually runs a bit better. We didn't see any errors in the previous one, but maybe we'll see some KQL errors in this one. Yeah, because here you can already see the network communication logs. It's not actually a table that I've seen before. And I'm also pretty sure that the file creation alerts, I don't know if these are actually tables that are available. So we'll see. So here you can actually see it really believes in itself. Right? It's really very confident, and it really says, okay, yeah, it really believes in its own conclusions. So let me skip a bit further. So what I actually did in this one, demo number 6, is it's what I said before, is I gave it the tool which actually first queries Sentinel to get the available Sentinel, the schema of the tables. And also what I also did was actually I gave it some examples of KQL queries. I think if here in the files, there is actually a file with a lot of KQL queries. And I gave it as an example for it to create the KQL queries used to do the analysis of the incident. So maybe let's run this one again. See, and here you can already see that it actually reached conclusion already, where it says impacted, but it's actually the same incident as before. So again, the inconsistency is actually a bit of a problem. And here you can see, okay, now it's actually getting all of the example KQL queries. Yeah, and here you can see the actual analysis of the incident. And then you would already suspect, okay, there is a summary. These are the incident details. We've assigned the close notes. But yeah, you would actually assume it would have already stopped because it actually reached what we thought it would, what we asked it to do. And here you can actually see that it's even when we give it the tables, And even when we give it example queries, it actually starts failing because the request has some invalid properties. Which I would actually think, how is that possible? You know the exact schema of the table of the database. So how can it actually be that you still have wrong queries? Yeah, that's something that you sometimes see, but then again, other times you don't. And also what you also see here is different agents still actually do very well, they do the same tasks. And that's the reason why I went from the round robin team to the team to the swarm. With the swarm, you can really define, okay, you need this agent needs to coordinate everything, and every other agent has very dedicated tasks. So yeah, I don't know how many times we've already seen a close reason and close nodes, but it just continues to actually send prompts and in the background. Meanwhile, this is just all consuming tokens. So that's actually what I mean, that in the beginning you saw the tokens consumed was actually very little, but yeah, it will add up. I'm just gonna stop this one and then go to the next one. An interesting agent type is actually the user proxy agent. It is actually putting a human in the loop. That's how it's called. I'm not going to demo it, but what this will actually do is we use the round robin again. So it will first let all of the agents actually do their thing, and then it will come to you, and then you can say, okay, can you investigate this more? Can you execute additional KQL queries? I don't agree with this. I don't agree with this conclusion. Can you do some of it? Yeah, I'll do some additional investigation. Maybe one more demo that I can do. I'll go back to the last one, to the most advanced one, quote unquote. What I did here is I added the getting the incident information from XOR, and also very interesting, which actually made quite some difference, is I asked AI to improve my descriptions. And that's what I would, if you guys start playing around with this, actually really, AI is very good at directing AI. So actually that's what I asked it to do. So a bit of guidelines if you create the descriptions and the system messages. Start with what the agent is, what's the purpose, type of tasks, all of the tools it can interface with, and really the important, what it shouldn't do. Because then it really knows what their task is. And specifically also for the system messages, again, just being clear, short sentences, don't leave room for ambiguity in the statement, because that's really what helps the AI. So maybe finally, let me run this one. And what you'll see here is that actually the SOC analyst agent delegates all of the tasks to all of the different agents, and then it's its responsibility to reach conclusion, and then also it's its responsibility to terminate the whole team, actually, to reach conclusion, say terminate, and then that's it. So here you can actually see the information which is gotten from XOR, which is gathered by our analysis playbook. It will do some additional, here it will get all of the schemas and the tables from Sentinel. Here it's actually doing additional queries to Sentinel. Here you will see the results from the KQL queries. It looks actually, it's one of the identity protection alerts that Erik also mentioned. So it's an alert about sign-ins to Azure AD. So of course, MFA is very strong authentication is very important. And it reached in the conclusion, insufficient information. What you will see the next time I run this, the close reason can actually be completely different. Okay, cool. I think almost on top of the hour, so let's end. Back to the slides, I guess.
Yeah, thanks, Wouter. Yeah, sorry, you stole my You saw my little Teams message there. Because I'm respectful of everyone's time, I think quite interesting. And you might think, okay, but based on that, it's very unpredictable, right? And that's a bit exactly the point that we're trying to make here. I think what you need, what we need to move towards is truly a layered architecture where you combine automation playbooks, SOR playbooks, which are honestly very predictable because you hard code them. You give them you give them a logic that they follow if then by, and that you know what's going to happen, right? You know exactly what's going to happen. It's also very cheap because once you've defined the logic, then it just keeps on running. They come at a little bit of a more expensive investment cost, of course, because you need to build all of the logic up front. You can, of course, add a layer of AI agents, right? But don't underestimate, there's still a cost, right? There's a higher run cost, but there's also an investment cost. As you've seen with Wouter, it's not like I'll just create a prompt saying you're a SOC analyst, figure it out. It's gonna be quite messy. And I think that's a bit the conclusions that we wanted to make. There's tremendous potential for these agentic AIs, but don't be fooled. It's gonna come at the right. We need to really still figure out how do we use this in security operations in a good way, especially if you're building this on your own. We're not making any conclusions here on all of the commercial offerings, to be fair, and that's also I'll be very explicit. That's the reason why there's commercial offerings, because there a lot of the heavy lifting on defining, refining those agents is done by the vendors themselves. If you're experimenting with this on your own, be aware that it comes at a certain cost and a certain level of unpredictability that you also have to take into account. So we shared the link here of all of the Python playbooks and everything that Wouter was demonstrating. So feel free to have a look at that yourself. You can always also join us at the Sense course. I'll be presenting at RSA next month as well. So happy to see you there. Don't know, Wouter, did I miss anything? Anything you want to still add?
No, maybe just to add from my side, I've actually just scratched the surface of the AutoGen framework. There's so much more capabilities like state saving, memory. If you look at Crudo.ai, what they rely heavily on is also a feedback loop. So this is just a result of my initial investigation, but I think indeed, as Erik said, this is a very deep subject. You can go very deep into this. So I think very interesting topic. We haven't seen the last of these agents yet, I think.
All right. With that, I think we're at the top of the hour. So I don't think we have a lot of time for questions, but you can of course reach out to us. Here you can see you've got our LinkedIn profiles. So we're pretty easy to find. So if you ever want to ask us a question, feel free to do so. We'd be happy to chat. Thanks everyone, and good night.